All right, let's jump right into a story that honestly plays out like a massive, cinematic corporate drama. I want you to think back to the computer boom of the 90s and 2000s. Do you remember those little Intel Inside stickers slapped on the front of basically every family desktop computer? You probably even remember that iconic four-note jingle, right? Well, for nearly half a century, Intel wasn't just participating in the digital age, they were literally building it from the ground up. But history has a funny way of showing us that even the most unshakable, utterly dominant empires can start to fracture. So today we are going to unpack exactly how the undisputed king of semiconductors lost its crown, the blinding effects of corporate hubris, and the desperate, insanely high-stakes battle currently underway to get it back.
In tech, yesterday's success is no guarantee for tomorrow. Now, I want you to keep this thought front and center in your mind as we go, because it perfectly sets the stakes for what we're looking at. We're talking about a company that truly had everything. I mean, limitless resources, research and development budgets that absolutely dwarfed the GDP of small nations, the brightest minds on the planet, and a market share that most monopolies would blush at. But here's the thing. When you are standing at the absolute pinnacle of an industry, the air gets pretty thin, and the only direction you can really step is down. Let's look at exactly how that descent began.
So, to really understand the fall, you first have to grasp the sheer, unfathomable scale of their dominance. For decades, Intel was the literal heartbeat of the global economy, and they achieved this by relentlessly driving something called Moore's Law. Basically, this is the principle that processor performance consistently doubles roughly every 2 years. And think about what that actually means in everyday practice. The smartphone sitting in your pocket right now? It is millions of times more powerful than the room-sized mainframe computers that guided the Apollo missions to the moon. No joke. And for over 40 years, Intel wasn't just casually following this law of compounding power. They were the enforcers. They dictated the pace of human technological progress, and they left every single competitor completely in the dust.
Okay, let's dive into this. How did they maintain that punishing pace, year after year? Well, they did it through this magnificent, highly predictable rhythm known as the tick-tock cycle. This wasn't just some clever business strategy on a whiteboard. It was a high-wire act of physics that Intel somehow just normalized into a routine schedule. Step 1 was the tick, physically shrinking the microscopic transistors on the silicon. Then, step 2, the following year, was the tock, completely updating the design architecture to maximize that new, much smaller transistor size. This two-step heartbeat gave Intel a massive vertical advantage. You see, they didn't just dream up the blueprints. They physically forged the chips flawlessly in their own cutting-edge factories, which are known as fabs. They controlled the entire universe of their product, literally from atom to assembly.
Section 2. The 10-nanometer wall, a high-stakes gamble that backfired.
Right around the year 2014, this unstoppable, perfectly timed manufacturing machine hit a massive, unyielding roadblock. The tone of our story really shifts here, going from triumphant progression to a sudden, screeching halt. And the trouble began with the number 10. The entire industry was attempting something near impossible, shrinking technology down to a 10-nanometer scale. Let's put that in perspective for a second. A single strand of human hair is about 80 to 100,000 nanometers wide. We are talking about working at a scale so infinitesimally small that classical physics basically starts to break down and quantum mechanics starts playing tricks on you. Pushing past 14 nanometers down to 10 was this monumental obstacle for the whole industry. And this is exactly where Intel's flawless execution finally stumbled.
The whole roadblock centered entirely around EUV, or extreme ultraviolet lithography. Now, EUV is practically alien technology. It's an incredibly expensive, massively complex system that uses perfectly timed lasers and mirrors to print at atomic levels, and it was absolutely crucial, like unconditionally required, to achieve that insane 10-nanometer transistor density. But Intel made a calculated choice. They took a shortcut. To save billions of dollars and maintain their tight vertical control, they thought they could just perfect their older existing manufacturing methods. It's the classic tragic flaw you see in a Greek drama, right? They genuinely believed their engineers were smart enough to bend the laws of physics without actually buying the million-dollar new tools.
And man, that hubris proved devastating. By avoiding EUV, Intel ran headfirst into a massive crisis of low yields. In semiconductor manufacturing, yield is everything. It's the percentage of chips on a silicon wafer that actually work and can be sold. Because Intel was stretching old technology way past its breaking point, too many chips were coming off the assembly line completely broken. This wasn't just a minor hiccup, it was a financial and business catastrophe. Factory lines essentially froze up. Major products were delayed by years. The famous tick-tock pendulum, that relentless clockwork that defined a whole era of computing, it simply stopped swinging. Intel's momentum ground to a devastating halt.
Section 3. Rise of the Foundries. A divided ecosystem conquers the giant.
And this brilliantly illustrates what happened next. Because while Intel was spinning its wheels in the mud trying to fix its 10-nanometer problem, the rest of the world absolutely did not wait around. Rivals capitalized on this stall, creating a totally new global power dynamic. On one side, you had Intel's traditional vertical advantage, that exclusive, closed loop where they design and manufacture everything in-house. But on the other side, the foundry model emerged. This is a divided, highly specialized ecosystem. Companies like TSMC, Taiwan's semiconductor manufacturing company, they focused exclusively on running the factories. This meant tech giants like Apple and NVIDIA could focus entirely on pure design and innovation, without worrying about the multi-billion-dollar headache of actually running a factory. They just sent their blueprints over to TSMC to be built. So while Intel was struggling alone, this nimble, collaborative foundry model absolutely exploded in power.
And this shift, it wasn't just a corporate reshuffling. It created an entirely new geopolitical reality. Because TSMC went all in on that wildly expensive EUV technology early on, they successfully bypassed Intel entirely. The unthinkable happened. Intel lost the process lead. For the first time in computing history, the absolute best, most advanced chips in the world were no longer being forged in Intel's factories in Oregon and Arizona. The crown of semiconductor manufacturing officially shifted across the Pacific to TSMC in Taiwan. Think about that. The advanced silicon currently sitting in the phone in your pocket, it highly likely came from an island in East Asia, not the American Pacific Northwest.
Section 4. The IDM 2.0 Pivot. A desperate but bold counteroffensive.
So the crucial point is, Intel finally woke up and realized the sheer gravity of their situation. They weren't just losing a product cycle, they were losing the entire decade. So they initiated this massive turnaround, bringing back veteran Intel engineer Pat Gelsinger to take the helm as CEO and execute a completely radical survival plan dubbed IDM 2.0. This bold strategy is twofold. First, they are pouring hundreds of billions of dollars, hundreds of billions, into physically building brand new fabs across the globe to forcefully, aggressively catch up on the manufacturing tech they missed out on. Second, and perhaps most mind-bendingly, they are opening their doors to become a foundry themselves. Intel is literally offering to manufacture chips for the very competitors who just beat them.
Think about the sheer magnitude of this pivot for a second. Intel is fundamentally transforming from a fiercely exclusive club to an open manufacturer. I mean, imagine the cultural whiplash happening inside the walls of that company right now. It is an incredibly sobering acknowledgement that the old do-it-all-alone model failed them when it mattered most. They are currently locked in a breathless race against time, radically and painfully transforming their entire business structure. They are trying everything to claw back the lost decade of dominance that just evaporated due to a single, fateful strategic gamble on physics and EUV technology. Which brings us to our final thought to wrap this up. Has the chip king been permanently dethroned? We've just watched an immovable titan brought to its knees by a single calculated gamble on physics, and now we are watching them spend hundreds of billions of dollars just to buy back time. Intel is fighting with literally everything it has, armed with a completely reimagined business model. But here's the catch. TSMC and the massive foundry ecosystem, they are absolutely not standing still. The outcome of this specific silicon race will dictate the future of the global digital economy for the next century. So take a moment to reflect on this massive scale. Can an empire of this size truly reinvent itself after falling so perilously far behind? It's going to be fascinating to watch.